The path of a ballistic missile is a perfect example of a downward opening parabola. Mathematically, its height over time follows a quadratic function. Gravity makes sure it curves back down, no matter how fast it starts. So every time you sketch a downward opening parabola, you're tracing the elegant, merciless path of something that was launched, and is definitely going to land. Quadratics have been making destruction predictable since ancient times. Maybe that's why parabolic reminds me of diabolic. Symmetry is beauty, and the parabola knows it. The axis of symmetry slices it perfectly down the middle, so every point on the left has a mirrored twin on the right. That's not a coincidence. It's baked into the math. The quadratic function is built so that inputs that are at the same distance from -b/2a produce the same output. I wish my eyebrows were as symmetric as a parabola. An upward opening parabola is the graph of a quadratic where the leading coefficient is positive. It curves gently into a single lowest point, the vertex, and then rises forever. It's the shape of optimism. No matter how low things go, it bounces back and the only direction left is up. This is a downward opening parabola, where the leading coefficient is negative. It climbs to a single peak, the vertex, and then descends forever. The graph reflects the idea of a maximum, a highest point beyond which is impossible. This reminds me of the rise and fall drama of life. Whether it's the life of a literal star or a figurative one, everything bright eventually burns out. In math, we call it a maximum. In real life, it's called your mid-30s. Do you know why every graph likes to hang out with parabolas with no real roots? Because they never cross the line. Everything that goes up must come back down, just like a parabola. Except teenage boys' motivation to impress girls after 15, that just skyrockets and never returns. Why did the business owner hire a mathematician? Because his cost function was quadratic, and his accountant couldn't tell the difference between a vertex and a vortex. A formula for the y-coordinate of the vertex? It feels like the ultimate extra, because if you already have the function, you can just plug in the x value of the vertex and get the y value directly. I guess some mathematicians are obsessed with fancy formulas. I totally agree with Professor Jordanson. At first, confidence is up. They've barely started and already think they're experts. That's the "I could teach this" phase. Then comes the crash. The more they learn, the more they realize they know nothing. But if they stick with it, confidence slowly returns, this time backed by actual skill and maybe a few emotional scars.